So now we're going to look at angle bisectors, segment bisectors, and perpendicular bisectors. So, an angle bisector is a ray. So remember, a ray has an endpoint at one side that goes on forever at the other. And it divides an angle into two adjacent, which means they're side by side, they share a side, and congruent angles. And then a segment bisector can be a segment, it can be a ray, it could be a line, it could even be a plane that divides a segment into two congruent segments. So if we look at this first one, if I know that BD is the angle bisector of ABC, then that means this top side is the same as that bottom side. So if I wanted to solve for x, all I would have to do is just set them equal to each other. So 8x minus 20 equals 5x plus 1. And then we just solve it. So I can subtract the 5. I can add the 20. So then we get 3x equals 21. And then we divide by 3. And so we get x equals, good, set. Questions? So then on our next one, we have this segment LN. If MP is the bisector, if LM is 3, what is MN? If it's a bisector, it makes it two equal pieces. If one side is 3, the other side is 3. Good. So if it's a bisector, it's making it two equal lengths. So then we could say the whole thing is how long? Good. Very good. Questions? Okay. So triangles, we know, are made up of 3 angles. So we could say the angle bisector of a triangle is a segment that bisects one of the angles of a triangle. And it always starts at a vertex. So vertex are your 3 points here. And a triangle has 3 of those. So it has 3 angles. So it has 3 angles that you can bisect. So if we, of course we could do it with our compasses, but this is pretty tiny. So if we just connected and kind of went like this, then this side and this side would be the same. We could go about like this. So this side and this side will be the same. And then we could go like this. And so these sides are the same. And when you get to math 3, you'll talk more about Like, it has a special name where they meet and stuff like that. But you'll do that in Math 3. Okay. So our next one, the distance between a point and a line is the length of the perpendicular segment from the point to the line. So, if I connect P with a perfectly straight line down here and made it perpendicular, and that's just a perpendicular segment. So then our next one is the angle bisector theorem. Says if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So equidistant means the same distance. So equidistant. So what that tells me is if we have this point B, if AB is our angle bisector, then that tells me that B is the same length from the top side of the angle as it is from the bottom side of the angle. So then over here, we could say this little segment is the same as that little segment. Is pretty much what that's saying. Okay. So if it doesn't tell you that it's a bisector, but it gives you this little symbol, that it's perpendicular and that they're congruent, like in this example 1, then we can assume that these two angles are the same. So then if we wanted to solve for x, we again would just set them equal to each other. So 3x plus 5 equals 4x minus 6. So then to solve it, we could move the 3 or move the 4, either one. Add the 6. So we would get 11 equals x. So x equals 11. So then example 2, same sort of thing. It tells me my angles are congruent. So then that means these little segments are congruent. So again, we just set it equal. So 6x minus 5 equals 5x. So then I could subtract the 6x over. So negative 5 equals negative 1x. And then what would be my last step? Get divided by negative 1. So x would equal 5. Questions? Okay, so 3 is a little bit different. So it says we want to find the measure of ABC. So we want to find this whole thing. If BD is the angle bisector of ABC. So then it tells me that ABC is 4x minus 6. Well, can I say 4x minus 6 equals x plus 6? No, because x plus 6 is the small side. 4x minus 6 is the entire thing. But if this is x plus 6, this side is x plus 6. Okay? Because they're equal. So then I can say the two smaller angles add up to be the bigger angle. So 4x minus 6 equals 2x plus 12. So I just add x plus x is 2x, 6 plus 6 is 12. And then we can solve it. So we can subtract the 2x over, add the 6. So we get 2x equals 18. So x equals 9. Go. But we don't just want to find what x is, we want to find the measure of the angle. So we take that 9 and plug it back in. So 4 times 9 is 36, minus 6 is 30. Questions? Okay. So then example 4 says CD is the angle bisector of this triangle. We want to find x if the measure of BCA, so this whole thing, is 80. Well, if it's the angle bisector, the whole thing is 80. What's each side? 40, yeah. So then we can just say 3x plus 1 equals 40. So subtract the 1, gives us 39, divided by 3. Questions? Alright, let's look at that side. So up here, perpendicular bisectors are segments that are perpendicular to a side and divides the side into two equal parts. So on these, it does not have to start at the vertex. And so a triangle also has 3 perpendicular bisectors. So again, if it's a bisector, it's cutting each side in half. So if I look at this side, we could say halfway is about right here. And if it's perpendicular, it has to meet it at a 90-degree angle. And then it makes these two sides equal. And then we could say the middle of this one is maybe about here. And so again, we want it to be perpendicular. And makes these two sides the same. And then same maybe about right here, perpendicular, makes these the same. And so your perpendicular bisectors will also meet at a point. It can be inside the triangle, it can be outside the triangle, but main thing is it cuts each side in half. So then the perpendicular bisector theorem says if a point is on a perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So then that says if we have C, it's on our perpendicular bisector, the distance from C to B is the same as the distance from C to A. So then example 1 right here, we could just set these equal. So we get x equals 3. So we just move over the 4x. And then same thing on 2, 3, 4. You're just setting them equal. Just making sure there wasn't something different, but there wasn't. So let's look at this proof down here. So this proof says we want to prove that the two triangles TWU is congruent to the triangle VWU. So we're given that UW bisects the angle TUV. So that's given. We're also given that they're right triangles. What's it called when it says WU is congruent to WU? Reflexive. So that's these sides. So then it tells me that WV is congruent to WT. Well, I know that because if we look right here at our angle bisector theorem, that's what it says. It says if it's an angle bisector, then it's equidistant to the sides of the angle. So that is the angle bisector theorem. And so if I'm looking at this, it's a right triangle. Which 5 thing tells me that these two triangles are congruent? If here's my right angle, what is this side in the middle called? Starts with a H. Hypotenuse, good. And then I also know this one, which is a leg. So we know that because it's hypotenuse leg.